What's going on, everyone? Homework assignment 52. Today's objective, I can create systems of equations from word problems. So we're going to go right into it. We're going to create the systems. I'm not so focused on solving of the systems because we've gotten a lot of practice with that. I'm just going to use this video to strictly talk about how to create a system given different types of word problems. I am going to ask you to copy all of the word problems, though. Okay? And I'm actually going to write it out because I know that some people are not going to see this. So I'm going to say right here, copy all word problems. Leave it there for a moment. Let's get to it. All right. So first problem. Jeb and Lori went to a florist to buy flowers. Jeb bought 6 roses and 3 carnations for $20.25. Lori bought 8 roses and 3 carnations for $25.75. Find the price of 1 rose and the price of 1 carnation. So we may end up using different letters to represent different variables. But the big thing that we want to know is that we're going to let's find out first what these variables are. So 1 rose and 1 carnation. So you could use X and Y still. There's no problem with that. Or you can use R and C, whatever works best. I'll use R and C for now. So R is equal to the find the price of 1 rose, price of 1 carnation. All right, so R is going to be equal to the price of 1 rose. So I'll just write 1 rose. And C is going to be equal to the price of 1 carnation. All right, so now all of the systems that we're working with are going to be a little bit different from each other. This one in particular is dealing with these 2 different people. So we have Jeb and we have Lori. Okay, they're telling us how much they bought of each thing here. So it says Jeb bought 6 roses. So first, we're going to have an equation to represent Jeb. So Jeb bought 6 roses and 3 carnations. So 6 roses and 3 carnations. So plus 3 carnations, and spent a total of $20.25. All right, Lori bought a total of 8 roses and 3 carnations for a total of $25.75. Okay, I like to call these systems, this specific type of system is whenever you're dealing with 2 people or 2 companies or 2 different things. In this case, we're talking about 2 different people. So Jeb has an equation, Lori has an equation. And then you can solve this one using whatever strategy works best for you. I would advise elimination, but whatever works best for you. All right, so right here, we're just focusing on the creation of the system. So let's go see another one. Again, copy the systems so we have them. So first off, let's talk about what exactly our variables are. All right, Jason has $2.25 worth of dimes at quarters. He has twice as many dimes as quarters. Determine the number of dimes and the number of quarters that Jason has. Okay. So Jason has $2.25 worth of dimes. So what do we want to know? Determine the number of dimes and the number of quarters. Okay, so let's do this. So let's go D is going to be equal to the number of dimes. And Q is going to be equal to the number of quarters. Okay. So if D is equal to the number of dimes, let's go ahead and let's create the equation. So the equation in this case, 1 is going to represent the number of coins. So one equation is going to be the coins. And the other is going to be, and it seems like it's kind of counterproductive, but it's going to represent money. All right, how much money everything is worth. Okay, so let's figure out the coins that we have. So it says he has twice as many dimes as quarters. Twice as many dimes as quarters. All right, so that means the amount of dimes he has is 2 times the amount of quarters he has. So then my equation here would be 2Q is equal to D. And let's see if that makes sense. Twice as many dimes as quarters. So if I multiply the amount of quarters I have by 2, I'll be given the amount of dimes that I have. Okay, so let's go ahead. Let's put this into, let's find the money aspect of it. So we know how much a quarter costs. A quarter costs 25 cents. Now I'm going to represent that with 0.25. All right, that's the price of every quarter. plus the price of every dime, which is 0.10, 10 cents, times D, is equal to the total amount of money that we have, which is $2.25. Now, again, I'm not asking to solve, but if we were to solve, I would probably advise going with the substitution method. I could take my 2Q and I could substitute it right here for D. All right, let's keep it rolling. C. Once again, I'm asking for us to copy the problems. I know it's a long one, but that's fine. No problem. All right, so this one says, a paper company needs to ship paper to a large printing business. The paper will be shipped in small boxes and large boxes. Each small box of paper weighs 35 pounds, and each large box of paper weighs 65 pounds. A total of 22 boxes of paper were shipped, weighing 1,040 pounds altogether. Determine the number of small boxes shipped and the number of large boxes shipped. Okay. So this looks like it's going to be representative of the amount of weight that each box is, and then just the number of boxes. All right, so what are our variables here? Determine the number of small boxes and the number of large boxes. Okay, so we can use S and L. I'm going to use X and Y. So X is going to be equal to the number of, I'll just write small, but we're talking boxes, and Y is equal to the number of large. We're talking boxes. Okay, so here's what my equations are going to be. So one equation is going to represent the boxes, or number of boxes. The other equation is going to represent the weight. Okay. Let's see what we know. Each small box weighs 35 pounds. Okay, so let's do the weight equation first. So each small box is 35 pounds. So 35 pounds times the number of small boxes I have, plus 65 pounds times the number of large boxes I have, 65y. And X is my smalls, Y's are my larges. And we know that it is in total 1,040 pounds. Okay, so all of this is representative of my weight. And let's go with what's representative of the boxes. We don't know how many boxes we have. We know that we have, if we add the total number of small boxes plus the total amount of large boxes, we'll have a total of, and it tells us right here, 22 boxes. All right, with that, we can use elimination, we can use substitution, whatever we want to in order to solve this problem, we could use. Okay, and I think that we'll kind of keep it right there. We'll leave it at that in terms of trying to create these equations. I just wanted to give you a few examples, but try these out. Go back, make sense of the equations, make sense of how exactly we're going to find the equations, and we'll get some practice with it tomorrow. Okay, I'll see y'all then. Any questions, as always, reach out to me.